Hello and good morning, good evening, good afternoon, and welcome to Discovering Neo4j AuraDB free with Michael and Alexander. Hey, Michael, how's it going?
Welcome. Hello, Alex.
Hi.
Good. Busy week last week. I was in London
Yeah.
and had lots of fun on Friday with the train strikes. I took the train back to Germany. So I arrived home like after midnight only, but it was
super late.
not too
Okay.
bad.
Nice. Yeah.
I mean, it could have gone much worse, right? So from that
Yeah.
perspective, I got lucky. Yeah, and
It's true.
otherwise,
At
good
least
weekend.
you arrived, right.
Yeah, exactly. Yeah, otherwise good weekend. Was very nice weather here. My dad had his birthday, and so we
Good.
had spent some time together as well. And so that was all good, and spent lots of time outside, kind of in the park and in the sun and cycling, and so recover from like all the days last week spending indoors. And
Yeah.
although
Definitely.
London is so walkable. I actually managed to get like 10,000 steps every day in London, which was quite nice. And it was beautiful, like weather-wise, it was really great. And I think only if you dislike Coronation and the Royals right now, then London is not a good place for you, because everything is construction sites for the Coronation. And
Oh no.
there
Yeah.
was also, I think,
Yes, true. Yeah. When is
on
that
May
again?
6th. Yeah,
That's
May
soon.
6th.
Yeah. Okay. Yeah.
Yeah, exactly. And then there was also London Marathon on the weekend as well. So there was lots of construction and
that's
kind of cut off areas, and so it was not so easy to get from A to B, because like when we want to go somewhere, there was some obstacle in the way. But otherwise, it was good to see some colleagues in the London office and then spend some time. And so yeah, we had a good time there.
Yeah,
How about
nice.
you? How was your week and your weekend?
It was good. It was the weather was not so good here, so it was raining a lot. The weekend was better. It was super nice on Saturday. So there is in Munich there's the opening weekend of the spring festival, I guess. It's like a little Oktoberfest, if you want. So it's
like a fair. It's pretty fair.
Yeah, exactly, yeah, like that. And it's on the same place where the Oktoberfest is, but much smaller. But obviously, because the weather was so great, everybody went. And they have a little flea market as well on the first Saturday, so we walked around there a little bit, but it was quite crowded, and then it was super hot. And we were not used to it, so we decided it's time for a shadow.
Yeah, we need to get used to it again.
Yeah.
Right? So
No, exactly. I said the same. It's like, okay, you since I don't know, September or so, we had weather that was like rainy and overcast a lot, and now all of a sudden it's 20 degrees or 20, 22, 23, and super hot sun. So it was like, ooh, I need more like a getting used to curve, not like binary winter, summer.
Yeah, it's really. I mean, it will get more extreme in the future, right? So I mean, April weather is usually quite diverse, but in general, I think we will see more of like very hot or very cold or very wet and very rainy episodes. So like the days of more like moderate climate are probably over now, and then we need to adjust for that. And yeah, which kind of brings us to our topic today as well, a little bit. I think.
Yeah.
And so you suggested for Earth Day we could look at some of the NASA data that's out there, and I have to say there's
let
so
me
much
quickly
data.
do an overview of what's going to happen. So if you're watching this for the first time, this is a regular series that we are doing to find a data set, an interesting one, and work it within an hour with AuraDB free, so which is Graph Database as a Service, which you can get for free, and we get from a tabular data or some kind of tabular data into a graph database, graphy data on a database. So that's the goal of today and of all these episodes. And Neo4j AuraDB free is, like I said, a database as a service offering. There's a free tier, so it's completely free. I will post a link in chat, and it's also in the video description here on YouTube. And then you can basically register for it. You get 200,000 nodes, 400,000 relationships. You get access to the Neo4j Bloom browser and data importer, which is the all combined in one tab in your browser, basically, which is the new workspace look and feel. So that's very handy. You don't have to juggle various windows around. It's all there. It's all very easy, and the user experience, I think, has gotten much better now, and it's you will see. Depending on how we get there, but on previous episode we showed that you can basically without writing a single line of Cypher, you can get from which is the Neo4j's query language, of course, but you can get from a CSV file with data importer, modeling it out, importing it into Neo4j, and then looking at it in Neo4j Bloom, which is the Neo4j visualization part, and see some relationships, maybe find some clustering, see some insights, and all of that without any queries. But today I left the topic blank because I wasn't quite sure what we're gonna do. So I'll switch over to your tab, Michael. Earth Day was on,
yes,
I think, and it was the yearly event that's kind of like celebrating or making people aware of the finite resources on this planet, and making people aware that there is no planet B, I guess, also, and then we need to take care of what we
very
have.
important to think about that.
Yeah. And that's a global event. And the NASA team, I think they have like for a couple of years now, but they made a few things available on their Earth data. So they have this page that Michael has shown here with all their data offerings. They have an API as well, and they have the Earth data part of it. And with this, they kind of make it available for people to explore and to play around with the data, and that's what we're going to do today as well.
Yeah.
Hi John in chat. Yeah. Hi Mike. Hi Mikael.
Because you mentioned.
Maybe. Yeah. Thank you for joining.
Because you mentioned it, I can definitely recommend the climate book. It's really good. Lots of essays, like 1 to 2 page essays of scientists, climate scientists, talking about all the different aspects of like water, greenhouse gas emissions, kind of land use, biodiversity, mass extinction, and what we can do. And then the other one, which I really like, is Saving the Planet Without a Bullshit. It's about kind of what we can do and what we can, ask our politicians to do, and how we can change before it's too late, right? So both of them really good. As such. Yeah, so with NASA data, the challenge is actually not so much the data or like as such, because there's actually too much of it. So if you if you look at this, like there are many pages of articles and data sets and so on. So it's more to get something that's actually workable in an hour as such. So for today, I wanted to start with something simple, and perhaps next time we could actually pick up something from the API or so. Because there's one challenge with NASA data. Most of the NASA data is in HDF format, which is a scientific hierarchical format, which can also include images and complex data and time series and lots of stuff. So it's pretty complex and big in terms of the data. And also, if you're not so familiar with the domain, let's say greenhouse gas emissions or floods or stuff like that, then you first have to kind of dig really deep into all these acronyms and what it means. So I tried to look into it a little bit, but it was just too much for the short time.
That makes sense.
To do. Perhaps that's something that we can do another time.
Yeah. Or if you watch this and are an expert on whatever you do, us know.
Yeah, please let us know. I mean, there's some Python libraries. Yeah. Exactly. So there's some Python libraries for reading the data, but that only gives you access to the data. You still need to understand what it means.
You need a meta. You need to be a meta expert as well.
Exactly, right. Yeah. And so they have articles on this, but they're all very like the general articles, right? So what basically how the HDF file is used and so on, but not saying, okay, this is kind of the description of this format, right? There's a lot of data on lots of different areas, right? So I wanted to look into like methane or CFC or water vapor densities and things like that. But it's all these data sets are all HDF files, right? As you can see here, right? So you can interact with this and search and select subsets of the data, and then it shows you interactively these. But then you get like a 30 to 50 megabyte download for each of them of an HDF file, and then you have to figure out, okay, what's actually in there. And there's also images in there and so on. So I felt it might be too much to look into that.
Yeah, you're probably right. Yeah.
Much of the data from NASA is actually from the MODIS satellite that captures both greenhouse gas emissions or in general atmospheric gas emission aspects with spectroscopy, but also can capture things like fires and temperature and other things as well. So which is pretty nice. So we also will use some MODIS data today. And I also found there's a lot of APIs as well. So we can also, at some point, we can do like an asteroids or exoplanet a session where we look at like space a little bit more. There's even an Mars Weather Service API from the inside.
Weather Service. That's good.
Inside rover,
I mean, you never know. You need to know what the weather forecast is like on Mars for the next couple of days.
But what they also have as an API, which I want to look at perhaps next time, is this Earth Observatory Natural Events Tracker, which had actually everything like from fires to cyclones to floods to other Earth events, basically natural disasters and so on. And so I looked at the API a little bit and should be doable in terms of how it works. So perhaps that's something that we can look at next time.
Cool.
Such. Right? But for today, I picked something simpler, which is the FIRMS data. So NASA has this really good fire data source with real-time fire information, where they basically detect the brightness and the kind of implicitly the temperature of certain areas, and can also do like smoke and other things. So they have real-time data for this, but you can also access the data in other formats, for instance, also in CSV formats that they call here TXT, which is quite useful. So what I did, I just downloaded the text file for the last 7 days, basically here from FIRMS, and you see that it's also MODIS data. So it's also so I picked this world data set for 7 days. With 1 kilometer resolution, right? So that's kind of what we like. We cover the whole world, and for 7 days, it's kind of what you can get here. If you want to drill down, you can get like for each day of the month individual files, basically here as well. If you look into that, then you get the breakdown.
Oh wow! So that's global.
So there's like all the data for the last 2 months is here, right? So and then you can get them and download them, right? So but it's beyond what we need.
Totally. Yeah.
Okay, before we get started, let's create the Neo4j AuraDB instance, so we can create a free empty instance for our needs. So I just click here on after logging into Aura. I just click create instance, and then it will spin up an instance here, and we can actually rename it to FIRMS, which is the NASA fire data set. And then we wait a little bit while we look at the data, and then we can get started.
And don't forget to download your password or save it. I mean, it's very easy nowadays, really just to click on the download button to download everything, and then you get everything there, because otherwise if you yeah, here no, that's not it. That's not it. But once you have lost your password, you have to either create a support ticket to recover it, or you have to trash your instance and
drop
create a
your
new one.
database. Yeah, until we get SSO at some point, then it will be easier.
Yeah. But for now.
But the download file has also now been changed to TXT file. So we had .env because for development you have env files basically for using it from JavaScript to Python or Java. So, but many people that are not developers had trouble opening the env files in their operating system. So now it's been renamed to TXT, so everyone can open it.
It's easier to open.
So.
And there you see the password and everything else.
Exactly.
And it's easy to change the file, I guess, to an env if
extension,
you are developing. Yeah.
Exactly. So so I got here my films file, which is I think 5 megs, 4.8 megabytes, and we can use XSV, our CSV toolkit that I really like to use, to look at how many rows are in there. It says 64,000 events, so it's quite a lot for. Is this actually showing
global?
correctly?
So yeah.
So that's for global 64,000 events in the last 7 days, right? So it's still quite a lot of fire-like things, right? And with XSV stats, we can basically look at the fields. So we have latitude, longitude, which is kind of self-explanatory. Brightness is a floating point number, which says how bright is this measurement. The scan, I don't really know what scan and track stands for. So we probably import it, but we probably ignore it. And then date and time information, which satellite took the recording, the confidence of like between 0 and 100, right? So how sure are we that this is a fire, or could be also just some reflection on water or some other heat production or something like that. Version, another version of the brightness, and then was it at day or at night? And I don't know what FRP stands for. So I don't think they had like the data explanation.
Yeah, I'm just seeing if they have a data.
I don't think they had anything in here, but somewhere probably they have the firm's explanation as well, right? So
here's a FAQ, maybe that says something.
Can probably also scan track FRP. Let's see.
What does scan and track mean? Let's see. The scan value represents the spatial resolution of the east-west direction of the scan, and the track value represents the north-south spatial resolution of the scan. Okay.
So that should be always 1 kilometer more or less, right? So because this is the 1 kilometer.
Yeah.
So that should be.
It should be noted that the pixel size is not always 1 kilometer. The pixel at the east and western edges of the scan are bigger than 1 kilometer. But yeah, okay, I think we can ignore this one.
And then we have here fire radius power, which is the radius emission per time unit. So it's a proxy for fire intensity. So that's what we can probably use for our visualization then as well. Right?
Yeah.
So we look at the FRP more and brightness probably. Temperature in Kelvin. Okay. Interesting. So we actually have brightness and FRP as fire strengths, basically. Nice. Good. So we have our data. Our Aura instance should be ready to go as well. As you can see now,
it's running.
Green and running. We can click on open here. And I have my password over here and paste it in. And then it opens our database and we can clear out our last thing. So it opens automatically in the query tab, but we want to import a CSV right now. So we switch over to the input tab. And it shows also our database name on top here, which is nice. And then we can select our firm's dataset here. And it's not so graphy as such, but we can actually turn it into a little graph later. So we can call it event or fire or recording. Perhaps we call it just fire.
Yeah.
The node. And then we want to map the data from the file. So we pick the latitude, longitude, brightness, scan and track. I don't know actually if we
I think we should leave it. Yeah,
ignore it.
Exactly.
Satellite, it's probably all the same as well. Version, you probably don't need this. And the brightness in so they said the brightness is the temperature, right? So that's in Kelvin.
Yeah.
That's not right. So you can leave this. FRP we need, and day night we can keep as well, right? So that's pretty straightforward. And if you say confirm, it also automatically detects that latitude, longitude, and brightness are floating point values. It always also determines that this is a daytime.
Easy now. Yeah.
Satellite is a string. I thought that confidence is actually, it's 0 to 100, so it's not a floating point, but it's an integer. FRP, our fire. I mean, we could actually also rename stuff. We could also say brightness is temperature and FRP is the fire.
What was it again?
Where did I have it? Somewhere up here. FRP, fire radiative power,
energy emission. Okay. Yeah.
Yeah. You can probably also rename it here as our, so that's more obvious. So I just call it fire radiative power. Day night is okay, and this is actually temperature, so you can call this temperature. Our ID is a good question because our observation doesn't really have an ID. It's a good question.
What is the uniquest value?
Yeah, what's the uniquest value? Or we need to add one.
Yeah, not even data is unique, obviously. Because
So what I did last time, I just created a new ID file. So there's a Unix command called seek, which gives you like just incremental numbers, right? And then you can basically say for I in seek, how much? What did we 64,000?
So it's at the top, yeah, 64,771.
So we just say echo ID on IDs dot txt, and then we should just say these IDs we just append echo ID and txt. Done. So we have also the same row count, and then I have to remember the syntax. I think there's an join or cat concatenate by row, so we can just say xsv help cat or xsv cat h. So we can just say we want to concatenate columns, and then we just say which file we want to write it to. Right. So okay, xsv cat columns, and then we just say our IDs.txt and our firms, and we write it to firms.csv. Okay. And xsv stats firms CSV has now this ID field from 1 to 64,000.
Oh, right? Perfect.
So or exists v then head, for example. Sample 10. So see, like it has the ID field as the first field, and then we can use it.
Oh yeah.
Okay. So
and then we see that that actually changes.
Yeah. So we just remove. Use the other file.
Yeah. No, but what I mean is there is a different satellite, so we could technically make satellite a separate node. Not sure it adds much value, but we could.
Yeah. How many satellites were there?
And in the thing there were in the T and A.
Yeah, it's just 2, I think. You can also add it.
No, I don't think that's really worth the effort. Yeah.
Yeah. So just let me delete this one again, and let's do this. Fire. Oops. Fire. Okay. Fire and add to select from file. Select all, and we said scan and track. We can ignore. Yeah. Version we can probably ignore this as well. Confirm, and then we said this is temperature, and this is fire radiative power. Yep. Right. Or we can call it something like strength or something like that, probably. I don't know. Yeah. Also automatically selects the ID, so this is fine, and then we can basically run this as a preview. I think this is a new icon for preview, which I find a little bit weird, but we see now our nodes here with all the data imported as a preview, right? So this is kind of what we want. So we can click on run import, and it should be pretty quick. So it's 5 megabytes of data, resulting in 64,000. Right. So it should be done in a few seconds. And then we can take the next step. Okay, so took 17 seconds, created 64,000 nodes from 64,000 lines, so there are no errors, and it created 647, so 10 properties per node as well, and in 6 batches, right? So if you look at show cipher, it also shows us what our ID is and how it imported the data as well, right? So if you want to use this later on, then you can also copy this to a script, and you can, for instance, replace this unwind with a load CSV or something like that, and then it gives you this information. Okay, if you go to start exploring, then we have our data, hopefully. Let's see. Show me a graph. Oh, it's interesting because we don't have any relationships. To show me a graph of any data. Yes. So interesting. So it's probably good feedback for the team that it should also show data if there's nothing in there. So what I thought we could do is you look a little bit at the visualization aspect, and then we can perhaps create a few relationships and see what we can do with that. But here with this data, the visualization should actually be quite interesting. So for one, we can make the nodes bright by brightness, basically, or by fire strength, right? Yeah. Or we make them basically brighter by temperature, as such, right? And so we say this is a range, and then we can pick like a reddish color here. Let's see. Here, down here. So we go to the red, more reddish, orange area. So we start. We can actually start where that is right now, and then we basically pick for the really fiery something in the dark red zone or something like that, right? Yeah. And the midpoint can be. We can probably also ignore the midpoint as such, right? So if I now say apply color, it should change the colors, as you can see already by this. Yeah. And then we can add another rule-based styling for the size, where we could say we actually take the temperature. No, that was the temperature. Sorry, the fire strength.
Fire strength, yes.
As range, but for size, and we say like the smallest one is 0.25x and the biggest one is 4x size.
Yeah.
Right. So it's pretty big range. So it should actually give us, as you can see, different sizes here, and you also see that it corresponds a little bit to the temperature as well. Many of the larger ones are more darker red than not, right? So there are some that are not as high, right? But in general, that's quite nice. So this and we could add an icon, but I don't think we need an icon for the fire if you only have one. So what we could do is we could add the temperature, for instance, here as an text. So currently it has confidence, which is probably not so helpful. Or we could do can put the date and probably the temperature or something like that as text. So we see kind of what day it was.
Yeah.
And then we can basically see a little bit what temperature it is. And now we can do something else, which is quite nice, is we can visualize this not with the 4-space layout that we currently have here, right? So which is kind of nice, but we can use the new coordinate layout as such, right? And we can use latitude, longitude for the XY coordinates as such.
Yep.
And
I think this.
No,
do we need to work on the scale, or does it?
Actually, it should be already. If you didn't mess around with the order, is it the other way around? No, it's latitude is.
I think it should be
the other way around, right?
Is it? I'm always confused.
Yeah, me too.
Longitude? Should we? Yeah.
Longitude and latitude. So I think this looks better. This would mean a lot of. This could be California, maybe also. So this could be US. This could be China also.
Like or Japan or something.
Yeah, Japan would be pretty much, right?
But yeah.
But I think this looks actually more realistic than the other one, as such. So, but you can zoom in basically and say, okay, for this fire, we can also double click it and basically say, we could actually find the place where it is, right? So
yeah. See if it makes sense, and then we need to play around with the scaler a little bit. I don't know if that.
Do you think we should reduce the scale? Let's zoom out. Or let's use this one. So you mean we should pull it?
No, yeah, you're right. No, it doesn't make much. It doesn't make it any better.
Yeah, it's not a big difference.
It's not. So, but no, it needs a map. But maybe let's
this one, which should be somewhere in South America, right? So then let's see.
I think you can, if you just type it in with comma separated the two values, I think it should be.
Yeah, I think you're right. So, and then this. But this is somewhere in Venezuela, right?
Yeah, okay. Then it makes sense. Okay, then it's correct. Yeah. Okay.
But it's right, so we can basically use them. I'm just looking at what I'm wondering if you can get the resolution for where it is as such. So the other thing that I wanted to look at is basically the time aspect,
Mm-hmm.
So we have now our geo visualization, more or less, of the data, right? So we have a bunch of fires in South America, a lot of in Asia, and then here, or perhaps is this perhaps even the US here over here? No, probably not, right? No, that's on the right side.
Yeah.
So what we could do is two things. So one is we can look at the time aspect, right?
Yep.
So if you look at the dates. Oh, we have don't have enough data. That's why it's in the.
Did we?
Yeah, because it only loads 1,000 nodes by default, and it doesn't have in this version of Bloom. You can't configure that, but we can basically use a Cypher statement instead for adding that. Let's do this. More fires. So we basically so it we can say basically limit 10,000 or something like that, right?
Yeah.
So that's why it probably also had. Let's see. Oh no, it just returns.
It's a hard-coded limit.
Yeah, but what we can do is order by random. So we get now every time new data in, because it adds to the scene. We should always get more
now
data
it may now it seems to be
right,
almost like a globe, like the map you used to know. Yeah.
Exactly. So this looks better, right?
Yeah,
so now you see straight.
Yeah.
So okay, our confusion was just a lack of data that we had,
Yeah.
right? So but every time we run this now, it adds 1,000 more nodes basically, right? So see, it turns into the world much better.
Yeah, much better.
Okay. I didn't realize that it's just the 1,000 nodes had been in a certain region, and now so this looks more like it, right? So good. So now we should also be able to see more in the slicer here for the acquisition date, where we can basically then look at. I'm not really sure why it's showing in this weird way. We had this once before, right? When when it didn't show.
I remember we had.
Do you remember what we did? Did we just reload and then it worked? Or?
I think you reloaded and then it was visible underneath the actual.
Yeah. So let's try this again. So I reloaded and now, yeah. So now it's underneath, right? So, and we should be able to add the range here again, and then what it can show us. So if you had all data in the graph, you probably need to run a few more queries. Then you can basically show how this spread of fire distributed.
Yeah, or if actually fire spreads around.
Yeah, or kind of the different days, what they looked like, if they were like
exactly
new areas popping up as such, right? And probably here are too few of those. Right.
Yeah.
So we can here get some more data in again. I'm not sure. After the reload, we lost some of our data, I think. But we can always get it back. The other thing that I wanted to look at is, so one is we can basically, for a few nodes, let's say for the biggest fires, we can actually add, try to get the geo information.
Yeah, there's a question, by the way, on chat from Michael. Is it possible to create a relationship to show all fires on the same date? You don't even have to create a relationship to do that, because we have already the property we have already stored in each fire, so we can we can technically just query all fires that have the property date X and then list them as a table, I guess.
I mean, we can. It's actually something that we can look at the data here, right? So if we look at our fires, we have in total 64,000, right? But then we can say acquisition date. Then it kind of groups them by date, and we see how many fires are there per date, right? So you see 8,700, 10,000, 11,000 fires. So that's by date. And then if you picked one of those dates, like this one, then we could, in the visualization even, if I clear the scene here, we can change our little query here, this one, and give it a parameter. And then we just say where n dot acquisition date equals date. We need to do of date. Get a date out of this, and then it's basically. Oh no, we can actually say this is a date time. Nice. So we can actually should be able to use this. And then it gives us the fires. The only problem is we have our limit with the 1,000. We can't change here. I know, right? And we can actually make suggestions where it actually gives us the acquisition dates as suggestions. We don't even need to copy this in. So and then we basically just say fires on, and then it fetches already the dates that exist. And then we can just pick one and then just paste it in, and then that's all the date fires on this date on the 17th of April 2023. And, or we can also then change it, say, and that's we also want to see the ones on the let's say on the 18th as well, and then it combines them into one visualization as such as well. Right. So we can also connect them to a date node. So sometimes it's interesting if you create a hierarchy of date information. Maybe you say this is kind of the date, the week, the month, the year. If you have more information to use it geographically. So that's something that's also possible. The other thing that I thought we could do is we can actually create relationships between the nodes. Where we say, for instance, if you want to connect like things that are close enough so that they cluster, for instance, we could say we find the closest nodes, the closest fires to an existing fire, and perhaps the top 3 or so, and connect them with a relationship as such. All right. So we find one fire, kind of, and it call it source, and then we find another fire, the target. And then for each source and target, we say we compute the distance, point dot distance of this is a point of source and a point of target. We can just use the nodes themselves here because they have this longitude and latitude attributes, and the point function can take directly something that is named latitude and longitude and turn it into a geopoint as such. And then we basically just take the top 3 targets for each source and connect them basically as such, right? So, and to do this for each, we can actually do this in a subquery. So we just say call with source, match fires. You probably don't want to have the source again, right? So you don't want to connect it to itself. So it's not the same.
It's not, yeah.
And then we say we can actually just return target order by distance ascending limit 3 or something like that. Right. So for each source we find the closest 3 targets basically that are closest to this, right? And then we basically just create a relationship between source close to target. We don't provide any direction here because it's bidirectional as such.
Yeah.
Right? And
do you want to include the date? So in that query above, the same day or something.
And target.acquisition here equals source.acquisition date. And then we just set rel.distance distance, right? That's in meters, if I'm not mistaken. And we could also set the date on the relationship, but that's also on the source and the target as well, right? So and let's just test this for a few nodes and then see how it goes with source limit 10 or so. And so this should find us. It's 20 relationships for a source node, and that's 30 properties. So if you do it for all of them, it's probably a little bit too much. What we can do is we just say with source order by source dot fire strength descending. We just do it for the biggest fires, right?
The biggest ones, yeah. Okay, that's good. Yeah.
And let's get the 500 biggest fires or something like that, right? Of the 64,000. And so for the biggest fires, it should now go ahead and find the closest ones and set those relationships. What we have not done here is we didn't create any indexes on acquisition date or
yeah, that would have probably a fire
so
strength
it will
as
take
well.
a little bit, yeah. On f.acquisition date, and then we can also create one on location if you want to do, but then we also need to create an location attribute as such as well. So which you can do while this other thing is running in the background. We can just do it as well. So we could say our fire gets a new attribute called location, and that's a point of can actually say point of f because it has latitude and longitude. So it basically turns
it automatically does
the latitude and longitude. Or what we would otherwise say, we would basically say longitude is f, just so that you see it, and latitude is f dot latitude, right? So you can also, if this is spelled something different, or if it's LNG and lat or something like that, then you can basically construct your point with the attributes as well. So we don't need it as such. We could just pass in f as such, but we can also do it like this. So it sets the 64,000 attributes now. And then this next time we run something like this here, it should be faster. But it also finished after a few seconds as well.
Yeah.
Cool. And now in our visualization, we can actually use these relationships, right? So we just refresh the perspective here. And now we have this new relationship called close to, right? And we can now fetch these close to relationships. So our show me a graph
the initial thing. Yeah.
Should now actually also return something because that now has like the 500 biggest fires with the relationships in there. So I think we broke our server a little bit, which shouldn't happen. So we can do this in a batched subquery. So we do it for each fire with in transactions of 10,000 rows or something like that. Let's see if it works. So this is running. Right. Yep. So now it's at the 64,000 properties. So basically, the AuraDB free instance has not a lot of memory available. So if you run too large statements, then it might choke a little bit. So that's why kind of doing something in transactions is actually a good way of doing it. So, and in our Explorer, we should now also see show me a graph with the relationships. And the biggest fires should now have relationships in here as well. We can't probably see them so well because they're too close. But if you clear out the scene,
exactly. Maybe we clear it and try again.
Do this again. So you see it shows only like single nodes almost, and here you see one relationship, right? And that's because if you zoom in here into one of these, then you actually see that they're on top of each other, more or less, right?
Yeah.
They are basically, the distance is probably like 0 or something like that, or 3.7 kilometers or so, right? So it's very close on a global scale as such, right? So and then, but that's kind of.
But I mean, that's most likely that now that if you look at the data, I mean, can you if you enable the slicer now, are these? Do we have
these are all
we don't have a time,
right? So otherwise
these all
otherwise they wouldn't. The time is a little bit weird because it's an extra attribute here. We should have. We would have to construct a new datetime property basically from the date and the time. But I wasn't really sure, to be honest, because the acquisition time, you see it's 22. Here it's come on. Acquisition time 22, acquisition time 1333. So I'm not sure if that's like minutes into the day or something like that, or seconds into the day, or I'm not sure. We should probably need to look it up in the FAQ what the time information is. So we need to construct basically a datetime from it as such. But that's definitely something we could do as such, right? So I'm just quickly looking at it at a time. One thing that I wanted to show probably is there's a function called, because I mentioned that we could probably add the geolocation for some of those fires as well. There's an epoch spatial geocode, reverse geocode, where we can pass in reverse geocode. So we pass in latitude and longitude basically. So fire dot latitude and fire dot longitude, right? Let's just get one fire and yield. We actually should look at what this returns. There we go. So we pass in the latitude and longitude. And we get location back and data and description. Okay, location, data, and description. That's what we get back. Location and description. And if you run this, return 3. So we see basically this is our fire. This is our description, right? So which has the full detail. Here we also get in data, we also get country code, town, district, municipality, postcode, and so on. And description would all have all the things. So we can actually set from the data, we can set the country code, the town, the district probably, the state, city district. So or region. Let's pick the town, country code, and country and region perhaps also, right?
Yeah, that should be.
So we just return basically, what is it, data? We can just reach into this. So we can just say country with a dot, country code, comma, town, we said, right? And region, I think that these were the things that we wanted to have, right?
Yeah, I think that's, region is.
And perhaps, I don't know, perhaps state, I don't know. As data, or as geo data. So, and now we can basically use this to set this data on our fire, right? And again, if we use the biggest fires, where we say order by f dot fire firepower, fire strengths, descending, right? And let's say we get the top 20 fires or something like that, right? And then instead of returning the data, we just add this to the fire with plus equals. We can just add these additional fields to our fire node. So we now have for each node this information as well. It will take some time because there's some throttling in these geo APIs that we don't overload the servers and don't get blocked as such, right? So it will pause for, I think, a tenth of a second or a second between the different calls. That's why it takes a little bit of time. There's also configuration that you can use for some of those geocoding as well. So if you use this on your own server, you can also pass in your own API key and things like that to make this faster. But let's see when it finishes, we should be able to see the data here as such. Right. If you're unlucky, it might all be in the same region, right? But in general,
well, but it doesn't matter. I mean, it's just for show, right? So
it's for demonstration, exactly. So let's see. This takes longer than I would have thought, but I don't remember exactly what the throttle.
Did we? The fire strength index, did we create that now or didn't we?
No, we don't. We didn't create one, but for only fetching them and getting them, that is super quick, right? So if I run this, that should be super fast. Turn F. Yeah, it's instant. So it's really the geocode.
Now it's done.
Is it done? Oh yeah. So it's at 95 properties. It took 2 minutes or so. So it's probably like a longer pause between them. Or we got additionally throttled by
maybe
by the API. But we can now look at basically what countries do we have. So we can basically say match fire return f.country. So most of them will be null, but we have basically Russia, United States, Australia, and this is probably something like Thailand or something.
Thailand or something, yeah.
Right. Let's see.
Laos. It's Laos on the right
side. It's really beautiful, right? So it's really
well, if it's not burning,
That's true. So that's kind of what we got in the ones that we returned, and for those we now also have other information, like for instance the town. Say where f.country is not now, so we don't get the null values. Return f, and you see now we have like the state, countries, and towns. For these lots and lots. So this
Australia,
is
that we can read it.
Dolní Vostočí federální okrug. What's the town here? Oh, there was no town returned. So this is in Guinea. This is Russia again. United States and North Carolina. Didn't return the town here. interestingly. North Carolina as well. So that was a very recent bigger fire. And in Australia, Western Australia, Ravensthorpe.
Yeah.
Right. So, but that's how you can use basically to augment your existing data with data from APIs. And then you can use this for visualization or for dashboard or app or so, right? So we could have done also like an Neo4j dashboard that shows like a map and the biggest fires and so on, right? But just to show you how you can basically get the data in, visualize it, and make use of it. That was kind of the idea behind this.
Yeah.
Right. And next time, perhaps you can look at the API and see if you can get data from the API as well.
Yeah, I think that could be fun. Yeah, that was cool. That was interesting. Even though initially, and that's probably also a good point to close this episode, is like in the beginning we had, okay, we only have a node, single node, no relationships.
Yeah.
And still it made sense to work that data in a graph because you we were able to discover something, we were able to analyze it and work with the data, even though it had initially almost no, well, it had literally no relationships, but we added then some, and even if we decided
and I think
for
this
this
is kind of
the geospatial view, I think it's very good.
And also the knowledge graph aspect, right? So now you could kind of get more data attached to it. You can basically add, I don't know, news articles, or like what are, like if you really add the municipalities, the towns and their population and kind of warnings. You could add other features like, are there related measurements from, temperature or wind or other things like, or, there's a lot of additional data that when you pull in like the societal and human data as well, right? So then you can say how many people have been affected, what's the region, and so on. So you can also do like polygon work and so on. Our colleague Will has done a workshop recently for building geospatial apps with Neo4j. So
shall I put the link?
Do you have the link quickly somewhere? It's probably somewhere in the live ones here as well.
Yeah, I got it here. I put it in.
Okay, you got it already. Yeah. Right. So that would be also something. Yeah, this one, right?
Yep.
Oh no, that was notes, but it's a similar one from notes as
notes,
well.
But still.
But it was also a workshop from Bill, right? And so you can basically use this as a starting point, what we showed you today, and then you can build out much more complex. You can also connect it to available materials from the fire departments or similar things, right? And or emergency response, and so there's a lot of other.
Especially right. Think about what we started a little bit with this close to relationship building. So we could develop this into something like almost like a fire spreading prediction engine, by saying, okay, there's a big fire. What's with a vegetation maybe layer on top of it, and can say, okay, this is how likely is it to spread to the neighboring region because it's dry woodland around. So
that's actually a good point, because if you use this, we could actually do something like see what's the difference in temperatures or something like that, right? So
I'm missing an E.
Temperature. So you could basically do what's kind of the temperature difference between the two files, right? So so you see basically and brightness. So is this something where they are basically building or forming like an decay of temperatures and power, for instance, right? And or not, right? So that's also something where you basically can say, okay, how does this spread along this, right? Imagine we had added all these relationships between all the subsequent nodes. Then that's a really good point, Alex. So you could see that as well, kind of and export visually as well, right? So for instance, here there's one that has very little difference, so it will be about almost the same size. So that's kind of probably one Actually, it's a good idea as well. You could actually use this information to also combine multiple measurements into one, basically. Where you say this is actually like one larger fire, right? So, and then based on distance and difference between temperature and fire strength, you can actually merge the nodes together and reduce the data size as well, right? So that's another thing.
Yeah, exactly. And you say, okay, maybe these two were, growing together at some, and then you have one bigger.
Or you can exactly, and then you can also create polygons on the outline of the fire and see how this changes over time, and so on. Right?
Yeah, and especially then with the slicer, you see, okay, how did it move around? Did it grow? Did it shrink? Did it expand in a direction?
Yeah, exactly. Yeah. So there are lots of opportunities.
Absolutely. Yeah.
Cool.
But that was fun. That this is the time we had today. So even though we could probably go on for another 2 hours on this, we let's close it here. Next Monday is the 1st of May, so that means bank holiday across many countries as well as is including Germany. So that's why we skip on the 1st of May, but we will be back the week after. Tomorrow there is a live stream on BioCypher, so I have Sebastian Lobentanzer join me on a knowledge graph, actually how fitting, knowledge graph for life sciences and healthcare building tool that he is developing with a couple of people. So to make it easier and more accessible for people to build their own knowledge graphs, to develop their knowledge graphs, and to work with the concept of knowledge graphs without a technical background as such. So that's happening tomorrow afternoon, and then on Thursday, Michael, you will be back with ChatGPT.
Doing some coding,
exploring
with ChatGPT.
And co-coding, I guess.
Perhaps you can look into this HFD or HEF file format. Or something else. Let's see what we can do as such. I was also thinking actually about, while exploring all this NASA data, there's so much in there that it almost needs a knowledge graph to kind of just show what's there, how do things kind of relate, and basically because it's so much, and if you see everything only in basically in tables of options, it's kind of hard to correlate them, right? So you don't know, are these closely related data sets, or are these kind of far apart data sets, and so on. So that would be actually something interesting to look at as well. Cool.
Yeah.
Sounds good.
Sounds good. Exactly. So that was it. Thank you very much, Michael, for your time and for the guide through this data set. Thank you all for watching. I hope you found this helpful and interesting, and you may maybe play with this as well at your time. Let us know. Obviously, if you have any feedback, anything to talk about, go to the community forums at community.neo4j.com. With your questions, with your comments. We always listen to what you say, or just type it into YouTube comments. That would also be a good place. Speaking of YouTube comments, give it a like and follow the channel if you can. That would be also great to see if you enjoyed this episode. And I think with that, have a good rest of the day, rest of the week. Hope to see you either tomorrow or on Thursday when we're back with more. And until then, have a good time.
Take care, everyone. Thanks for watching, and glad you liked it. And see you next time.
See you next time.
Bye-bye.
Exactly. Bye.